Hello everyone, today I want to practice with you solving a homogeneous differential equation. We're going to use this example up here. So remember that when you have a homogeneous differential equation, you want to check if the right hand side of the equation gives you or has the property that if you multiply x and y by a factor, you get back the original function. So let's say what we are trying to check before we proceed with the typical substitution for these differential equations is if we multiply x and y by a factor t, are we going to get back the original right hand side of the equation? And in this case, I think it's probably obvious that we are going to get back the original function because we're going to be able to factor out at from the numerator and the denominator. So we have 7x minus y divided by, and you factor out at t, we have 1 minus 2y, okay? And notice that the t's go out, cancel out, and you get back the original right-hand side of the equation. Now, we have checked this, so let's move on. We're going to make the following substitution. We're going to say that let v be equal to the ratio y over x. Remember that a homogeneous differential equation has the property that this function on the right is truly a function of the ratio y to x, and that means that it is really a function of whatever number this division gives you, and we're calling that number v. That's how you can think of it, and that is why we're making this substitution. And that means that, well, anytime we see a y, we're going to write vx, and we want to write dy dx in terms of v and x, so we're going to do dy dx is going to be equal to d dx of v times x based on this substitution. Okay, we're just differentiating this equation so that we can rewrite dy dx. Using the product rule, we know we're going to get dv dx times x plus v times the derivative of x with respect to x, that's 1. So we only get v. Now, let's see what we can do. So we can set this equal to the right-hand side of the equation in terms of v and x. So I'm going to continue down here. We can say dv dx times x plus v is equal to, and I'm actually going to put the v on the right-hand side of the equation. So we're going to have dv dx is equal to 7x minus, so we have y, which in this case is vx, divided by x plus 2y, that's going to be x plus 2vx. And remember, we have this x, but we moved it to this side of the equation, so it becomes negative v, okay? And this is great because notice that we have a common factor of x in this expression, so these x's are going to cancel out, and in the end we are going to get a separable differential equation that looks like this. dv dx times x is going to be equal to 7 minus v divided by 1 plus 2v, okay? And finally we have the minus v, which we can write as minus v times 1 plus 2v divided by 1 plus 2v, okay? And I do this because that's going to allow us to combine these two terms. Nice. So then I'm going to continue up here and let's see how we can solve for v. Remember that when we solve for v, that's going to give us some expression that we can undo a substitution we did, and that's going to give us an expression in terms of y and x. And we'll see if maybe we can solve for y in terms of x, which is pretty often you cannot find y in terms of x, or at least not without like 30 more minutes of work. So in this case, I'm just going to give you probably an implicit solution if we get to that. So let's see. So we're gonna have dv dx times x. That's an ugly x. I'm sorry, but that's an x. That's gonna be equal to. So let's see. There's gonna be 7v minus v. Those v's go out. So we have 7v minus v plus. Well, actually minus v. I'm gonna write out the entire thing just so that we don't make any mistakes. And then this is minus v. And then this is minus 2v squared. 2v squared. And then we divide by, we just have 1 plus 2v. Okay, the same denominator. Nice. So yes, that is what we get. And of course, you can combine those two guys. And this is a separable differential equation. Okay. So I'm gonna move the v's to the left, and that's gonna give us dv divided by, let me make that bigger. So this is gonna give us, I'm gonna say 1 plus 2v divided by 7 minus 2v minus 2v squared, and then this entire thing, there we go. This entire thing, we're going to integrate it with respect to v, and on the right hand side we are going to get dx divided by x, and we're also going to integrate that, okay? Now this is really great. Even though this looks a little difficult, there's a pretty clever substitution that you can do. So check this out. We can say that I'm going to say let u be equal to 7 minus 2v minus 2v squared. That means that du is going to be the derivative of this times dv. So the derivative of this expression is going to be minus 2 minus 4v dv, okay? And notice the following. You could factor out a negative 2 from here, and that's going to give you negative 2 times 1 plus 2v, dv, okay? And this is great because 1 plus 2v dv is our numerator in the integrand. So we can make a really wonderful substitution like this. We can say that 1 plus, I'm going to write out the entire thing just so that we're, let's say, mathematically elegant. This entire thing, this quantity, is going to be du divided by minus du divided by 2, okay? So we can rewrite this integral as minus 1 over 2 in front, and then we multiply this by, we integrate, so the negative a half comes out in front, and then this quantity just becomes du. Then we divide by u, and it should be equal to the right hand side, which is just ln x plus c, okay? And the left hand side becomes minus a half ln of the absolute value of u. I'm not going to write u, I'm going to write actually the original expression in terms of v. So minus 2v minus 2v squared absolute value, and this equals ln of the absolute value of x plus c, okay? So this is what we get in the end. Now this is pretty wonderful because now we can exponentiate, do the algebra, and find y and x probably in an implicit form. Let's see what we get. So let's multiply by negative 2 on both sides. That's going to give us the ln of 7 minus 2v minus 2v squared. 7 minus 2v, blah, blah, blah. This becomes minus 2 ln x. And then plus c. Now the negative 2, remember, c is just any constant, and that is going to absorb the negative 2, so I'm just going to write c again. And now I'm going to exponentiate both sides, and I'm going to get 7 minus 2v minus 2v squared. And now let's see, on the right, that is going to be the same as if you had e to the ln x to the negative 2. So that is going to be x. I'm going to say e to the c just becomes a constant e, and this is going to be x to the negative 2, okay? Which is the same as just doing a divided by x squared, okay? Now I'm going to multiply by x squared on both sides of the equation, and now it is time to undo our v substitution. Instead of leaving v, we can write y over x. So it's going to be x squared times 7 minus 2 times y over x minus 2 times v squared, that is going to be y squared divided by x squared, okay? Close the parentheses, and this will be equal to some constant a, okay? Nice. And now, some people, so I think, depending on what your teacher wants, this may be a totally valid solution. Actually, no, let's make it cleaner. I'm gonna multiply by x this entire expression, just to be, just for completion. This is gonna be minus 2xy. So I'm just distributing the x to every term, and This is gonna be minus 2y squared, and then this equals a. Now this, I would argue, unless you can find a way to solve for y in terms of x, there might be a way. However, at that point we're just really doing algebra, and there is really no more differential equation theory that's involved. Maybe there is, but it would be in a very specific case. In general, after this point, you're not doing any more differential equations. So I guess I would argue, yeah, this is probably, yeah, I don't see any way you could simplify this any further. Yeah, I don't think so. So yeah, you could certainly leave your answer like that. And I think that would be valid. And I think for most professors and teachers, they would accept this, okay? So I hope you enjoyed this video. I hope you learned something. This is a very simple differential equation, but you can see a process gets maybe fairly long. This would take you probably around 10 minutes to do, around 10 to 15 minutes. Some integrals like this can become a little ugly, especially if you have to do something like partial fractions, or if for some strange reason you may end up doing integration by parts, then it can get a little longer, but overall this is what we get, okay? And it shouldn't be more than like 15 minutes, if you're in an exam. So I hope you enjoyed this video, I hope you learned something, and see you in the following one. Bye.